Okay, hello everybody. Let's get started with some introductions so we can introduce the students, including me and our professor here. I guess I'll go first. My name's Sam Berry. I'm a junior at Bryn Mawr College and I'm a physics major. Kate, do you want to go next?
Sure, I'm Kate Gold. I'm a senior at Bryn Mawr College, and I'm a math major, and I have physics and astronomy minors.
I can go next. So, hi, my name's Hannah James. I'm a junior and I'm a double major in physics and astronomy.
Hi, my name is James Garland. I am a junior astrophysics major at Haverford College.
And hi, I'm Julian. I'm a junior Goddy. I'm a senior physics astronomy double major at Haverford College.
Hi everyone, I'm Karen Masters. I'm a professor of astronomy and physics at Haverford College.
Thank you. Okay, so we're going to get started here, and I want everybody to know we'll have a couple presentations from all the students here, and if you have any questions, you can use the Q&A function, and we'll try and give a little bit of time if there are questions after each talk to answer them. And then also, like always, if you're not new to these events, we'll have Ask an Astronomer Anything around 9 o'clock. Where the students can answer questions and our professor Karen Masters can help us out if we don't know an answer. Okay, so without further ado, I'll kick off on this public observing night. Our topic is Mars, and for one big reason is that me and Kate have a planetary geology class that's focused on Mars, and because a rover landed on Mars recently, Perseverance, and it's kind of been a big deal. So we thought it was fitting to do an event based on Mars. So I'm going to share my screen. Okay. Can you see the PowerPoint? Okay. Always have to check. Okay, so I'm going to discuss the relationship between Mars and sci-fi. And again, this kind of stems from the geology class me and Kate are having with this amazing professor, Selby Hirth. She's a geology professor and she does a lot of historical archival things at Bryn Mawr. And she kind of kicked off our Mars exploration with its history. And so you'll probably recognize what this background is. I, of course, have to credit it as A New Hope. But like, this is one of the biggest franchises, science fiction, science fantasy. I've heard it called science opera. But we're going to explore kind of, I don't know, some kind of origins of how that exploded and how humans got interested in this subject. Okay. So to start off, I'm going to be talking about a very short time period from about the late 1800s to the early 1900s, basically just 1900. And it's about how science fiction relates to human observations of Mars. And there have been many notable observations of Mars all across human history. I think anybody that's here today knows that it's human nature to look up at the sky. So I'm going to select just a few historical moments in time where humans have documented them looking up at the sky, specifically at planets. So on the left, look at the laser pointer, we have a ceiling of an Egyptian tomb, this astronomical drawing on an Egyptian tomb from 4,000 years ago, which is incredible. And I don't read hieroglyphs, but I was told that up here in the corner, they have comments on the 5 naked eye planets, which is Mercury, Venus, Mars, and Jupiter and Saturn. And they gave them this funny name, or this funny saying, as the stars that know no rest. Because as you'll see, the planets, when we look at the night sky, we see all these bright objects, but the planets kind of move in a particular way that humans have noticed across time. Another notable society is the Song Dynasty in Beijing with Xing Zhu. Him and his colleague Wei Pu mapped orbital paths of the moons and the planets. yeah, 1,000 years ago. Okay, so one more mention of a societal like term with this odd movement of the planets, and specifically Mars again, is the Cree Nation in Canada, Canada's largest First Nation. What we call retrograde, like the scientific term for how the planets move in a particular way across our sky, they call Musa Axka, or something like that. It's called Moose Spirit. And it's basically called that, retrograde is called that because when a moose gets frightened, it runs in a big circle and then continues on its way. And I thought that was really fascinating. And that comes from this science podcast, Sci-fi, which I highly recommend. It's like a 10-minute long episode. But yeah, to just kind of explain in more detail, the reason it does this backwards motion is because if Earth and Mars were like in a race, it happens when Earth catches up with Mars. So it'll repeat. You'll see Mars is ahead, Earth catches up, Mars falls behind, and then Earth kind of completes its orbit and Mars goes on the outside again. So it's this wonky movement that people have noticed. Okay, so that was all before telescopes. And I just want to comment, like, that time before telescopes, Mars and the rest of the planets were kind of viewed as like untouchable, celestial, like spiritual places that were not physical. It was only when like humans started to view Mars and other planets with like physical telescopes, that's when they started to see them as physical objects. So you might know this grumpy looking man. This is Galileo Galilei, and he's credited with the first observation of Mars with a telescope in 1610. And like with more observations, scientists and people started to think, these physical places, these physical planets, like, are they similar to our own? So another credible person is Francesco Fontana. And he drew this image of Mars that he saw in 1636 and this one in 1638. And he is credited with the first drawing of Mars done with a telescope. So a semi-famous scientist communications writer, Willy Ley, reflected on Francisco's drawings in 1956. And he said it was probably just a poor telescope, because what Francisco is trying to show here is that this white object is Mars, and it has this black object on Mars that he called a very black pill. So like if you saw this in a paper, you'd be like, oh, there's a black object on Mars. And, that's kind of not true. We know that now. But this kind of introduces us into falsely seeing things through telescopes, which happened a bit more often than you would think, and probably still does. So this kind of map and others I'm about to show are called albedo maps, and they're very convenient, in an age where you don't have cameras. You just draw the darkest things you see. So it's like light and dark contrast. So basically, I'll show another one. You look at a picture, you're looking at Mars through a telescope, and you draw this dark thing that you see, like you sketch it out. This is an albedo map. So this guy I included because he is from the 1600s, but he was an original supporter of aliens. He was Christian was a Dutch astronomer, and he's credited, so many accreditations, for the first drawing of Mars that showed terrain on Martian's surface, and that's what this is, in 1659. He, like I said, he was like an original believer of life on Mars. This is a quote from his book, The Celestial Worlds Discovered, and he says, "The planets may be allowed some bodies capable of moving themselves, not at all inferior to ours, for why should they? And these are animals. Now, for fear of starving their poor creatures, we must have plants, So he's basically saying, like, this is a planet, and these are people, and they have animals, and they have plants. Like, it's a reflection of our own place. And this was in the late 1600s. So now, this is our main player of this talk, Giovanni Schiaparelli. And he shares my birthday, March 14th. I was born in 99, not 1835. But this is a picture of him from 1890s. And then this is just a drawing of his. This is different from the other maps. This is showing possible like areas that Mercury crosses, but we're not dealing with that. So this is the map that we're dealing with. This is the map that kind of blew up the scientists and some authors that we'll see in a second. But this is Giovanni's observation of Mars during opposition in 1877. And what is opposition, you might ask? It's when Mars is conveniently close to Earth. So you'll see that the sun is here, the Earth is in the middle, and then the planet, Mars in our case, is on this side. And it's very close. And the conditions are just really nice. So other conditions for Giovanni were also nice. He had a very nice telescope at the time, and his books and like lab logs, I guess you could say, he talked about how the dust was clearing up for him on Mars. So basically, he drew an albedo map, and this is very detailed, and it's kind of like, do you imagine those maps of the world that we have, where like all the things are like flat and kind of proportioned out? Like this is a map of Mars, like the entire planet. And he drew all of these features, and you can see like there's a bunch of dark lines everywhere. So he, being the scientist that he is, he published a paper, and him also being Italian, gave names to these, new formations because it's a new field of science. They called them canali, which means channels, like saying, in his idea, he was calling it channels as a way to show the reader that they were natural, like features on the planet. It's like channels of like natural water or something, but natural. But of course, this was mistranslated into English, and it got turned into canals. And this is much different. Canals apparently implies artificial construction. So suddenly people were like, this guy is telling me that something put canals on Mars, like something made canals and put them on Mars. And not only that, they put them across all of Mars. So there's some species on Mars, and they're far more intelligent than us, because fun fact, the Suez Canal, which has been in the news, was also created around this time, more closer to the 1900s. And that's a very tiny thing compared to a canal all across the planet. So people were like, whoa. So like I mentioned, this topic was brought up in my planetary geology class. And my teacher, when she brought it up, was saying that like a kind of, I don't know what you'd call it, but like a fun theory to think about this. Because we know, and you may know that because you're at this talk, that Mars does not have canals. Like we know that now, we see pictures. So why did he see this? Like, why did he draw this? And the fun theory that my teacher brought up in class is that he might have been looking through a misaligned telescope that was actually reflecting the veins in his eye. So like, I like to think of this as like, if you're looking through binoculars and they're a little out of focus, you see like your eyelashes magnified. Like in this case, it's a much bigger magnification, but like he saw his veins and started mapping them. Possible. But then there's also this theory. I couldn't help but share this when I was researching. There was apparently an experiment in 1903. This is the actual title, Experiments as to the Actuality of the Canals Observed on Mars, where they took 20 boys and lined them up at different distances to look at like spears with different painted symbols on them. And basically they found that if there's a bunch of dots on the symbols, they'll form canals, like the boys will form canals. So just trying to disprove, trying to be a hater, but yeah. These guys were not that. They were the exact opposite. Nicholas Flammarion, not saying that right, but he's a French astronomer, and he wrote this book that I will also not try to pronounce, but I think you can tell. The planet of Mars has habitable conditions. And he was a super big proponent of, there's no water. They're making these giant canals. Like these species must be advanced, but in trouble, which makes me think of Dune. I don't know about anybody else. And then there's Percival Lowell, which I always say wrong. This is a wealthy guy who I think he is an astronomer and mathematician, but I think he's known for his wealth because he made the Lowell Observatory. And a big reason for that is because he wanted to kind of prove and further our understanding of the Martian canals. And I couldn't find an exact date, but somewhere around 1900s, like he did use the telescope and he apparently confirmed that there are canals and vegetation. But some things that happen to scientists is that if you're looking for something, you find it. Doesn't mean it's true. Okay, and to sum this up, because I see we have some questions and I have 2 minutes. The actual science fiction. I'm sorry to smush it all in one slide, but just look at these dates from 1880 to, of course, H.G. Wells in 1898. Just books about characters going to Mars, traveling the solar system, jumping between planets, and then, of course, aliens attacking. But it's really crazy to just see how excited humans get about Mars and about this possibility, and how imaginative we get. And so I kind of hinted before, during the space race, we did end up disproving canals with the Mariner mission. We saw that the planet was very dry and in fact looked quite dead. However, here we are today with a new rover on Mars, which we'll probably hear about later from Hannah, Perseverance. And literally, like just yesterday, it didn't drop the helicopter yesterday, but just yesterday the helicopter like started rotating its propellers. But there's this tiny drone next to a big rover on Mars right now, and that drone's gonna fly around. So it's just incredible. And although Mars looks dry and dead now, there's a lot of geological evidence for water in the past and like crazy climates in the past that we're still investigating. So they might not have giant aliens, but there's things to come. Okay. So stop that real quick, and I wonder if I can take one question. No, we should probably move on, but we do have a Q&A at the end that we can get to. So James, would you like to take it away?
Sure. Let me just share my screen real quick. Oh, sorry. Could you see my presentation just then?
It was black.
Cool. One moment. Sorry about that. There we go. Yeah, so I'm going to be talking a little bit about what we do at Strawbridge Observatory when we want to go observe Mars. But also, one of the things that I think Sam's talk illustrated really well is that Mars has been observed through a large range of technologies and history, and a lot of that is still accessible to us now. So I'm also going to talk a little bit about naked eye observing of Mars and observing Mars with our kind of professional telescopes, and a little bit of what's in between that. So the first thing I'm going to do is I'm actually going to leave this and I'm going to go to a different website. One of the questions you might have if you want to observe Mars is, where is it? The sky, we can get a bit more of a specific answer. This is a website that I really like, that I think is very convenient to go to. It's timeanddate.com. It gives you information about time zones and things like that, but it also has this really handy kind of calculator that tells you a lot about the positions of the planets in the sky. So this is, there we go, live to where I am right now. And one of the nice things you can do on this website is you can just click Mars, and it even tells you that is the period of night when it'll be optimal to observe. So here, it's going to go below the horizon, and here it's still daytime. So this is a way that within a couple of minutes, you can see, when I go outside, what time should I go to look at Mars? What direction do I have to look in west right now? And I'll send a link to this website just after. So naked eye observing of Mars is kind of fantastic, I think, although some people might find it a little underwhelming. I think it's really interesting for a number of reasons. So one thing is that Mars is a really stunning object in the night sky. Though sometimes you might look and just think, oh, there's a star there. if you know what you're looking at as Mars, and I'll talk about that in a second, it is probably the most brilliant, bright red-orange object in the sky. And a really quick trick to see if you're looking at Mars or any planet for that matter is that if it's not twinkling, it's a planet, and if it's twinkling, it's probably a star. So this is great. You can do this also with binoculars. I use like a pair of birding binoculars, so nothing too fancy. And even below that, if you keep in mind where Mars is, over the course of a month, you'll be able to see just naturally that it actually starts moving around in the sky and track things like that retrograde motion happening. So next I want to talk a little bit about taking pictures of Mars, because I think that's a bit better to talk about for a visual medium like this. Obviously, if we were at the observatory right now, we would all be able to take a look. But I'm just going to show a few images of Mars, some of which I've taken, some of which I haven't. So the first one I took on this telescope. And I show this because this is about the most basic, like entry-level telescope that one could get. It's definitely still in an accessible range. It is, at least mine is a now 8-year-old bar mitzvah present that is still serving me very well. So this is a picture that I took with this telescope, I think last August, just from out of my window in my room here. The camera situation is a little different, but for now, I just kind of want to use this to illustrate that with like this level of gear, you can still get really stunning views of the planet. So one step above this would be taking a look at the 12-inch telescope that we have at Strawbridge Observatory. So it's the smaller of the 2 telescopes that we have. So using the same camera, and I'll give some hints into the kind of the technique that goes on here. I went to the 12-inch telescope last October looking to take an image of Mars when it was at opposition, and it was very bright and large in diameter in the sky at the time. So one of the cool ways that we take pictures of planets that's a little different from pictures of nebula or things like that in space is that we want to take as many pictures as possible in a short amount of time because there's a lot of atmospheric interference, and then see if we can put together a good image out of those. So to demonstrate that, I have this is that telescope, by the way. I have the footage that I took that I eventually turned into a photo. So originally, this is what I was dealing with. I took about 10 minutes of video like this from the 12-inch telescope at Strawbridge. And you can see kind of bits of detail going in and out, but because of the temperature differences in the atmosphere, there's something called atmospheric turbulence, and it plays into this concept of seeing, which basically talks about how easily you can pinpoint an object in the sky, like how precise it will be. So there's kind of a lot of wiggling around and things like that. Thankfully, we have some really great software that allows us to put these together and find all the best bits from the different images that make up this video. And that turns it into a picture like this. So this is, I think, I want to say about 200 frames taken out of about 20,000 images that I took in this 10-minute period. And then, and this might seem like CGI or something like this, but I promise you that everything that is here is in the next image. You can process it a little bit and you end up with a much sharper image like this. So it might seem a little surprising. This is all data that was in that original video. So that is one kind of thing that's personally interesting to me, is that Mars is absolutely stunning to look at in person. And I think it's really interesting that we have to find alternative routes to getting the same kind of results when we want to take an image. And this is, I think, a nice image. You can get a lot of surface detail out of it comparatively. You can see a bit of the northern ice cap there. The next image that I want to talk about, yes, this is another kind of amateur astrophotography image that was taken by somebody on an astrophotography forum that I'm on. I think this is just a really interesting demonstration of how we can do really interesting kind of science with like amateur level technology. So this was all taken with, I think, an 11-inch telescope. And what we see here is a series of images of Mars several days apart. as a dust storm kind of begins to swell and then go back down. So I think that's really fascinating, being able to actually see the weather on another planet. And that is using the exact same method that I just showed previously. So I have one more set of images that I want to talk about. Let's see here. This is the 16-inch telescope that we have at the observatory. So this uses a very different method of imaging. It uses what's called a CCD camera. And this is the kind of camera that one would use if you want to do actual scientific research and get data that can be processed and analyzed. That said, it can be used to still make really stunning images. So about 8 months ago or something like that, there was a conjunction of Mars and the moon. And what that means is that Mars was very close to the moon in the sky. And one of my classmates, Jesse, took some really fantastic photos of Mars passing by the moon. The reason why I say that is because the moon and Mars, when they were doing this, the scales of the orbits are so far off that even though from our perspective, maybe they seem really close, if you actually zoom in, you'll see Mars moves quite quickly compared to the moon. They kind of graze by each other. And so what happens here is that we take several images in different filters to combine them into one color image. And because of the time that it takes to take one image, the next image, and the image after that, we end up with this kind of stoplight effect. So what we have here is the moon all aligned up on top of itself, which comparatively did not move much. But when we took the blue image and then the red image and then the green image, you can see Mars moved a little bit. And so this is an alternative image in which we've kind of aligned Mars onto itself and let the moon show that offset. So that's all I have in terms. Oh, I have one last image just to bring things all the way back. This is a photo I took on my phone of the same event, which is very much a low quality image. It was a lot more stunning in person. But the reason why I took a picture with my phone at the time was because it was walking out of my doorstep and seeing this in the sky. And it was just an absolutely stunning sight. And I wish I could have captured it a bit better. But I guess the best way I can phrase it is that I think that naked eye observing can produce the amount of enthusiasm to think that this is a noteworthy picture taking. So yeah, I'm happy to open up to any questions about kind of how to observe Mars at any of these levels or about observing in general.
Yeah, we have a few minutes available if anybody can use the Q&A function to ask a question.
In the meantime, I can show something else that we use. So that website was really great, and I think it's very accessible. But when we do our observing at the observatory, sometimes we want more precise information or calculations about the motion of these objects. So you can take it one step up from that website and download a piece of software totally for free called Stellarium. Stellarium basically simulates the night sky from whatever location on Earth you want at any time. That means you could see what it'll look like 1,000 years in the future, or as it is right now. I have it from Strawbridge Observatory right now. So if you were to go to Strawbridge and look west, you would see Mars as it is right there. So this is really useful for us because we get all this information that gives us kind of astronomical coordinates for looking at Mars or any other object. This is something that we can put right into our telescopes and it'll help with the guidance. And if we want to plan when we look at Mars in advance, again, you can change the date. There's something that is questionable to try out live, but they have a calculations window and it allows you to see like when will a conjunction of Mars and the moon happen in the next 10 years. And it'll give you a list of all the times that Mars and the moon will pass right by each other. So that's a very interesting piece of software. That's very fun to just kind of play around with and see what cool events in the sky will be happening at any time.
Yeah. So We do have a question, but let's move on to Hannah's presentation, and we have that question saved and we'll come back to it.
Okay, so I'm just going to share my screen. Present. So as Sam mentioned earlier, I'm going to be going into more depth about rovers and landers, and specifically at the end I'll talk more about the Perseverance rover. So firstly, there are three things that we mainly use to explore Mars at the moment: an orbiter, a lander, and a rover. And there's examples of each on the slide. So firstly, an orbiter, it performs its mission while remaining in orbit of the planet, as the name suggests. It flies around the planet making observations, looks at the weather, it maps, and it's often communication relays for experiments on the surface. A lander basically just lands on the planet and it performs experiments using its robotic arms, so it kind of like reaches out and does stuff like that, whereas a rover, again in the name, basically roves around on the planet completing its experiments. So it moves around usually under its own power. So today I'll be discussing more the landers and the Perseverance rover. So firstly, Mars was first explored by the US in NASA's Viking project. This project involved 2 orbiters and 2 landers, one of which is pictured here. So the first Viking 1 was launched August 20th, 1975. Viking 2 was launched September 9th, 1975. So the Viking project, they took photos, which one of the image is here. They also analyzed Martian soil, wind, and atmosphere and sent the results back to Earth. The 2 landers also completed 3 biology experiments, which I think is pretty cool, with the purpose of looking for life. So the results of these experiments were the discovery of unexpected chemical activity in the soil. However, they didn't provide clear evidence for the presence of microorganisms. This is because, according to scientists, Mars is self-sterilizing. They believe the combination of solar ultraviolet radiation that saturates the surface, the extreme dryness of the soil, and the oxidizing nature of the soil chemistry prevent the formation of living organisms in the Martian soil. So I'll be going into a little bit more detail of life on Mars as we progress. But the Viking 2 lander ended communication on April 11th, 1980, and the Viking 1 lander on November 13th, 1982, after transmitting over 1,400 images. And I think it's pretty cool how long they last, especially how early on the technology is. So next we have the Pathfinder in 1996, so about 20 years later. It was designed as a technology demonstration of a new way to deliver an instrumented lander and the first ever robotic rover to the surface of Mars, which I think is really cool. Pathfinder not only accomplished this goal, but also returned an unprecedented amount of data and outlived its primary design life. The lander and the 23-pound rover carried instruments for scientific observations. And they also provided engineering data on the new technologies being demonstrated. So the Mars Pathfinder returned 2.3 billion bits of information, including more than 16,500 images from the lander and 550 images from the rover. So findings from the investigations carried out by scientific instruments on both the lander and the rover suggest that Mars was at one time in its past warm and wet. So examples of the Mars Pathfinder scientific instruments include an alpha proton X-ray spectrometer, which determined the elemental composition of the rocks and the soil. So Pathfinder discovered a lot. Some of its top scientific findings include that early morning water ice clouds were seen in the lower atmosphere, and there was also abrupt temperature fluctuations were recorded in the morning, suggesting that the atmosphere is warmed by the planet's surface, with heat convected upwards in small eddies. So now I will go on to a less successful mission, which is kind of sad. This is the Mars Polar Lander / Deep Space 2. This was launched in January 1999, and the goal of this mission was to land a spacecraft near the edge of Mars's South Polar Cap, and dig for water ice. Deep Space 2 consisted of 2 probes that were designed to impact Mars's surface in the hopes of testing new technologies. However, these were both lost upon arrival in December 1999, which makes me kind of sad. But yeah, anyway, moving on. So now 2004, 2 very successful rovers. We have Spirit and Opportunity. They landed on opposite sides of the red planet. So they had far greater mobility than the 1997 Mars Pathfinder. They trekked for miles across the Martian surface, conducting field geology and making atmospheric observations. They carried identical, sophisticated sets of science instruments, and both rovers have found evidence of ancient Martian environments where intermittently wet and habitable conditions existed. So the further we go with the rovers, the more likely it is that life was on Mars at some point. So first among the mission's scientific goals was to search for and categorize a wide range of rocks and soils for clues to past water activity on Mars. So the rovers were targeted to sites on opposite sides of Mars that looked like they were affected by liquid water in the past. So each rover bounced onto the surface inside a landing craft protected by airbags. When they stopped rolling, the airbags were deflated and the landing craft opened. The rovers rolled out and took panoramic images. So one of them is shown here that I got directly off the NASA website. They have all of the images, which is very cool. The images that the rovers gave scientists the information they needed to select promising geological targets to tell part of the story of water in Mars's past. So the rovers then drove to those locations and beyond to form close-up scientific investigations. So since leaving their landing sites, the rovers have sent hundreds of thousands of spectacular high-resolution images of Martian terrain, as well as detailed microscopic images of rocks and soil surfaces to Earth. So with data from the rovers, mission scientists have reconstructed an ancient past when Mars was awash in water, which I think is so cool. So Spirit and Opportunity each found evidence for past wet conditions that possibly could have supported microbial life, and that was a big deal. A very big deal. Both rovers exceeded their planned 90-day mission lifetimes by many years. Spirit's final communication to Earth was March 22nd, 2010, and Opportunity was June 10th, 2018, which that was a very long time. So now brings us to Phoenix Lander. This lander was launched in August 2007 and landed in May 2008. So in the continuing pursuit of water on Mars, the polar regions are a really good place to probe as water ice is found there. So Phoenix landed farther north than any previous mission at a latitude equivalent to that of northern Alaska. So during the course of its 3-month mission, Phoenix dug into an ice-rich layer near the surface. It checked samples of soil and ice for evidence about whether the site was ever hospitable to life. I don't think I said that right, but you know what I mean, if there was life there. So to analyze soil samples collected by its robotic arm, Phoenix carried tiny little ovens and a portable laboratory. I think that's so cool. I think everything's cool, but I think that's also pretty cool. Selected samples were heated to release volatiles that were examined for their chemical composition and other characteristics. Phoenix stereo camera located on its 2-meter mast, it used 2 eyes, they're not actual eyes, but 2 eyes, to reveal a high resolution perspective of the landing site's geology. Phoenix also scanned the atmosphere up to 200 kilometers in altitude, obtaining data about the formation, duration of movement of clouds, fog, and dust plumes. And it also carried temperature and pressure sensors. So a lot of these landers, so we're interested in if there was water on Mars, but also a lot of the landers researched the atmosphere of Mars, because that can also give hints about whether life could or has been on Mars. So now I'll move on to the Perseverance rover, or sometimes called Percy, which I think is really cute. So for anyone with a love of astronomy, February 18th, 2021 was a very big day. I remember it. This was the day that the Perseverance rover landed on Mars after being launched on July 30th, 2020. The rover got its name from Alexander Mather, a 7th grader from Virginia, who won the Name the Rover contest. So Perseverance has 4 scientific objectives. The first involves investigating the habitability of Mars. The rover looks for and identifies environments that had previously been capable of sustaining life, more specifically microbial life, including microscopic organisms such as bacteria. The second objective is to seek biosignatures, which involves looking for signs of microbial life in the habitable environments found in the first objective. Perseverance will look particularly in rocks that are known to preserve signs of life. Third, Percy will collect rock and soil samples with its built-in drill and store them on the surface of Mars. These samples will then be picked up by a future mission, which I'll mention a bit later on, and brought back to Earth for detailed analysis. Finally, if that wasn't enough, the rover will see if Mars could be suitable for humans by testing oxygen production from Mars's atmosphere. And that is very cool again. So these past studies of Mars show the importance of learning more about the red planet, especially in trying to uncover past life. Percy is built on the knowledge distilled by previous landers, and without them, Perseverance would not be possible. So besides Perseverance, there are 2 other landers currently on Mars. The InSight lander, whose purpose is to study the deep interior of Mars, and the Curiosity rover, whose purpose is to investigate whether Mars ever had the right environment to support microbes. There's also a couple of future missions in the works. One example is the ExoMars 2022 rover, which is shown on the slide. The goal of this rover is to understand if life ever existed on Mars. A big question. It will collect samples with a drill down to a depth of 2 meters and analyze them with next generation instruments in an onboard laboratory.
Minutes, and there is a question.
Okay, I've got like probably 1 minute left. I'll just get to the important stuff. So yeah, the primary objective of this is to land the rover at a site with high potential for finding well-preserved organic material, particularly from the very early history of the planet. So they just basically want to see if there was life or not. That's like the big question. There's also another future mission called the Mars Sample Return. That is just to bring back samples, as I mentioned earlier, that have been left on Mars by other rovers. So one question that people often ask, why Mars? Why do we care? Why is it so important? So Mars is the most accessible place, apart from our own planet, of course, in our solar system. Being able to explore Mars in great detail means that it could help us answer many important scientific questions related to our own origin and the evolution of life. Mars could also be a destination for humankind one day. Therefore, understanding it may be vital for the survival of our species. The end.
Nice. Seriously, all that stuff is so cool.
I just massively geek out. I could honestly talk for hours. Like, having to stop was slightly painful.
It had to happen. Okay, but we do have a question about this topic. We do have a question on James' topic, but let's do Hannah's topic first. Somebody asked, is Perseverance a robot rather than a rover?
So it's called a rover, but I guess a rover is a type. They're all like robots because they're automated things that kind of drive around, but it comes under the name of a rover because of what it does. Karen, do you want to explain that a bit more?
No, I don't want to explain it. I just want to, does anyone know the light travel time to Mars and back, right? Like if you had to drive the thing live, How long of a delay would there be?
Oh, is it like 7 minutes?
I think sometimes maybe, but I think sometimes a bit longer. And so, you know, if you tell the rover to turn right, it would keep turning right for a long time and hit a rock. And so they have to be autonomous because of light travel time.
Also, like, this isn't very relevant, but is that like in the movie The Martian, where there was always a delay with like the messages?
Yes, he puts up the sign and then he has to wait for
Yeah.
ages, and then he
Yeah.
puts up the yeah, absolutely. That
Okay.
one's quite an accurate representation of
Good.
what it would be like to be on Mars, I think.
That was also why I think during the day that it landed in February, there was those 7 minutes of like fear or something like that, because we had to wait 7 minutes for it to tell us that it survived the landing.
The longest 7 minutes ever.
Okay, well, Kate, would you like to take it from here?
I can definitely take it from here. For, I guess, one of our last activities today, we're going to be talking about how we can make a little cardboard rover. And so I have some slides I'm going to share. And so I think when we were thinking about this and planning, we were calling it a craft, but sometimes calling it a craft almost minimizes the work behind it. And so we can also think of this as an engineering project, and we can think about it as a science project. I think something that I was doing when I was creating these slides and my own designed rovers is I was really doing a very scientific iterative process of, okay, I'm going to try something, I'm going to test it, and then I might improve it after that. And so I think that beyond being, say, just a craft where the arts are very important, we can also say that this is going to be an engineering project. And let me see if I can go into presenter mode. Awesome. So what we see here on the right is similar to the rover that we're making, and you can always add color and change little things about it. But this is the general body where there's two larger wheels. There's a rubber band tension system, which helps propel it. And then there's the body of it, and that's the main structure. Additionally, there's two front wheels as well. And a lot of the items which you would need to make this rover on your own are available, say, within your household. I'm pulling these instructions from a JPL tutorial, and that's standing for the Jet Propulsion Laboratory. They created this tutorial for how to make a cardboard rover, and you can find more information using that tutorial. And you can also watch these slides later on. This presentation will be on YouTube, and so you can go to the YouTube video, which will be made available afterwards, and further take time to go through these slides. But briefly, I just want to go through some of the materials. A lot of them you will have around your own home. I should also note that I'm using the images from the JPL tutorial. These are not my own images for the most part, and so I want to give them credit. But to make the larger, to briefly go through the materials, the body of the rover that you can make is made just out of a square that's a little bit bigger, and then the recommend using the wheels made out of a little bit smaller squares. Additionally, we have you using like a number 2 pencil, a few rubber bands, and then something like lifesaver mints, and then a plastic drinking straw. You want it to be plastic so that you can kind of secure the ends of it by bending it. But I found that a colored pencil was working similarly well. And so you might have a colored pencil, if not also a drinking straw. You're going to need a ruler to measure it, and then tape and scissors to also help out. And so the first thing to do is to make the body of it. So getting the larger square and folding it into thirds, and that forms the body. And then having with the wheels poking a hole in the center of them. And that allows you to attach them to the pencil, which then becomes the axle. And so this tutorial recommends using the pencil to poke through the cardboard. And additionally, if you're doing something like that, you want to be very careful not to injure your hands. And so in these next images, they're showing how you can attach all the pieces together, where say in the bottom, we see that there's the body, and on each side we have the wheels. And the wheels, I found when I was using a pencil, the wheel that was on the sharpened end of the pencil was hard to attach. And so they recommend using tape to secure it to the end of the pencil. And then for the other wheels, these images show how you can use a drinking straw and feed like lifesaver mints onto the sides of it. And it actually is a surprisingly good fit. And so then securing that with tape on the ends, and in order to secure these as additional wheels. And then the specific knots I can go into, or you can look up on your own. I'm not going to go into detail, but you can create a rubber band chain, and the elasticity in the rubber bands is useful for the tension. And then you basically wind it up, and then whenever you release it, it will roll across, say, a table or the floor. You attach the rubber bands to the rover at the very front of the rover, as you can kind of see on the bottom right, with a few small slits, and to the pencil that you're using for the back, the larger wheels. And so that's a very brief intro to the tutorial, but I was able to make one, and I'm not quite sure if this video will load, but you may be able to see this little rover, say, in motion. And of course, this doesn't have scientific instruments, but I think the making of it is somewhat scientific, and it can be. And so this is the second version that I made. Yeah, so I'm going to see if the video plays. It may not play, but perhaps I can post it on one of the social media channels after. I'm not sure. Yeah, I have them with me. I can show you. Let me turn my background off, and I'm going to stop screen sharing. And then I can introduce you to my little rovers that I made. And I'm calling these prototypes. Let me see. Am I still screen sharing?
Yeah, you are.
Okay. And so I have, this is one of the rovers that I made. And this was following the directions, but something that I found was that the square wheels actually made it more complicated. And using a pencil made it a lot harder to align. And so I tried to follow the instructions very carefully. But with the sharpened end, I found that it was hard. It was kind of wobbly. And so I didn't find it very easy. But I made a second one, and I made some modifications. And so one of the modifications I made was to have round wheels, and I found that that was a lot nicer. And then let's see. I used a colored pencil instead of a drinking straw. And I used a Muji pen because with the cap on the pen, it's kind of like flat on both sides. And so that made it easier to attach the wheels. And I promise you that it actually does, it does work, it does move. Even if you, whether you follow the tutorial or you are more creative or otherwise creative, I found that it was a really interesting project. I'm going to go back to the slides just for a moment. Yeah, I should have done more planning to see if my video would load, but I can post it later, and it'll be available there. On Facebook and Twitter, to be more specific. And so here I just list some tips, and I find it, there's many things that you can do. Say if you don't have the materials available, there's many ways that you can work on this project. And for example, you could use a cereal box instead of cardboard. I found that one of the first ones that I was trying to make, I was using a thicker cardboard, and it actually had 2 layers of cells. And so it's preferred to use one with just like a single layer of like the little cardboard cells. I found that works. You can use hair elastics instead of rubber bands. I had a bit of alignment trouble, but that's something that can easily be troubleshooted. But overall, it's a scientific process. It's an engineering process. And it is a really fun project. It might take you maybe an hour or so if you want to work on it. But I think it's a good one, and there's many other similar tutorials on the JPL website. So
Can you show, like, can you wind up that rover? Because like on the website, it shows you winding it up.
yeah, I can do that for sure. So here, let's see, there's a loop on here. And so what you can do is just spin this axle, and so it will wind it up. And whenever you release it, then the wheels will turn. And whenever you have it on a surface, the larger wheels here and the smaller mitts will turn in tandem. And so it does roll across. And I think this one I chose to use 2 rubber bands. But if you would have 3 rubber bands, then you could increase like more tension, and then you could roll it a further distance. And so you do it just by spinning it. And let's see. Yeah, you can just spin it up and then it will unwind. And so it's the elasticity of the rubber band which propels it. And then one of the last things that I have here is that these instructions are also available in Spanish. And so if that's a language which someone is familiar with, this might be more accessible for them. And there's a link included here for that PDF. And finally, if you have further questions on this, we always enjoy having crafts at Public Observing. And now that it's online, we're trying to find ways to include that as well. And you can also email us if you would like to share a project, or if you were able to paint it, or I don't know, add stickers to it or something. So always fun to see everyone's projects. So.
Thank you so much. Okay. Cool. Oh, so I guess we do have a question concerning that experiment, Kate. Somebody asked, what are the square wheels for? But yeah.
So I think it kind of hops. It's a hard to describe, but if the wheels are hops, if the wheels are square, then I can't show the rover with the background on, but if the wheels are square, then it sort of hops across the ground. And so I think that it's entertaining to look at, but I find that as far as like distance, you would go a further distance by having round wheels.
Unless you're on a rocky field, like a plane on Mars, then you might find that square wheels help you get over little obstacles and things. I don't know, that would be a great experiment to build one with round wheels and one with square wheels and stick it in your garden with a bunch of rocks and see which one goes further.
Yeah, I know the wheels. I think on your Perseverance, maybe Hannah, you can speak more to this, but they are like super ridged and thin.
Yeah.
I want to say on the Perseverance that the wheels are made of metal. And so that's because we wouldn't want a rubber tire to puncture. No one can come and do a tire change. On Mars, it's too far, right? But whenever there's so NASA made audio files available, and you can hear sometimes like the wheels turning and hitting the rocks, and that happens. I guess like collision happens. I don't know if collision is the right word, but it happens. This like metal on rock. Yeah, and so I think that that's really interesting. You can find those audio files online. That NASA made them available.
Okay, so now I think we can go into our Ask Our Astronomers Anything Q&A session, where you can ask any of us anything. You can use the Q&A function. But first, we're going to go back to the person that had a question during James's presentation, while other people are thinking of their comments. But please use the Q&A function while we're answering this question. So a question from an audience member for James says, could you describe again the method by which you recorded the first picture of Mars and how did you process it? I wonder, do you think the one with the video?
Sure. Yeah, so the first image in which Mars is smaller and the latter one were both done with the exact same method, which was that video method. So to kind of break it down into the steps that go into that, the first thing is recording video. You can genuinely do this with like a webcam that you buy from like Staples or something, and just kind of rig it up to a telescope. So if you get that footage, there are several different pieces of software which I can like put links to or the names of in chat that I use. The first one, what it does is it basically has an algorithm that tells you what are the highest quality frames in that video, picks just those ones out. Then I have a second piece of software that picks out the kind of the highest quality parts from each of those frames and puts them together. And then the last one is for like filtering and kind of just like touch-ups. So I can put the names to those software if you want to kind of check them out. It's all free software online. And if you want to kind of learn anything about this, I highly recommend checking out this online forum called cloudynights.com. They have really excellent advice and like tutorials on this kind of stuff. So.
If there aren't any current questions, I did find a really good image of the Perseverance rover wheels, which I'll quickly share. And it just shows a comparison between the Curiosity rover and the Perseverance rover. So here they're little like zigzaggy, I think they're called chevrons, I don't know, I just call them little zigzags. They're zigzaggy here, and here they're more gently curved and there's twice as many treads. So they clearly learned from this one that these types of wheels would be better, and these ones are slightly thinner as well.
Thank you for that. Okay. Well, since no audience members are having any questions yet, I guess I'll go to Hannah again. What's your favorite rover on Mars?
Definitely Perseverance. That sounds kind of just like, oh yeah, whatever. But I think it's because this is the first one where I was kind of old enough to actually appreciate what was going on. Because like, obviously when you're younger, you do see things on Mars, you're like, oh my God, that's so cool. But now I actually understand the science behind it, which that was like a big thing for me. I was like, wow, I actually understand something that's on another planet. And I also wrote an article about it, so I did a lot of research, and I don't want to say connected to it because it's a rover and that sounds kind of weird, but like I'm very invested. I'm going to be watching what it discovers.
I'd just like to reflect that I have a similar relationship with the Pathfinder rover, and I was probably about the same age as you all are now when that one was landing, or a little bit younger, I think. But it's kind of interesting to think that it's the what, I don't know, I was super into finding about what Pathfinder did and the Sojourner.
Yeah.
And I worked in a planetarium one summer when I was an undergrad. And the main program was all panoramic images from the Pathfinder and Sojourner.
That's so cool.
So I got to see that show many times.
I'd love to see that. Yeah, Perseverance is what made me want to do a PhD in engineering. So I've got a lot to thank to Percy.
Just a reminder that this time is for you guys to ask questions for any astronomy question, not just Mars that we talked about today. Anything professional, being an undergrad, anything. And thank you for the thanks in the chat. You know, I do actually have a question for you, Karen. James using the time, I forget very what it's called, but the time website, do professional astronomers and astro people still use those free websites to check?
Not free ones, no, but there's, the equivalent. There's different, either an observatory might have their own custom one. So today, many astronomers are frazzled and busy today because many of us, including myself, have put in observing proposals to use the Hubble Space Telescope. And as part of that process, we had to download and use some software that the Space Telescope Science Institute put out, which lets you calculate when you can see what you want to see from the Hubble Space Telescope, which is a bit different from a ground-based one. But I didn't have to do any of the calculations. It was all provided in the software, and so different observatories will have this. in coding in Python, there's a number of routines that you can do to get this stuff as well. So there's like a package for visibility at different observatories. I think in the advanced observational class, or actually no, maybe it was an intro astrophysics, a sophomore class, we used it and did some calculations with it. So it's not hard to do, but yeah, not usually using timeanddate.com, which makes lovely visuals, but our software is usually a bit more basic in terms of the visuals it makes.
Got it. Okay, we do have a couple of questions rolling in. First one is from Sam. Could you go more in depth about the light/time difference when observing rovers for progress on Mars?
Yeah, I can go into a little bit of detail. It's basically Mars is really far away, to put it simply. And there is a delay because of that. I just found some statistics that for the Curiosity rover, so a couple of years ago, this delay will be 13 minutes and 48 seconds, about midway between the minimum delay of around 4 minutes and the maximum delay of around 24 minutes. So they have to make sure when they build the rovers that they can move safely, but also quickly and effectively, because you've got that big time difference. You don't want to see the rover going into something or like it's about to break and you're like, oh no, I need to stop that, because you're going to be too late and the rover will break and your life will be over. So you have to just make sure that you take the time into account when you are doing all your stuff.
And I'd just like to comment, it's not one time, because as Sam showed, right, Mars and Earth are orbiting around the sun. And so sometimes they're both on the same side of the sun, and sometimes Mars is way over the other side. And so I Googled it, it's 3 to 21 minutes. So 3 minutes at closest, but that's one way as well. So you're watching the rover and, you know, at closest, that was 3 minutes ago, and it will take another 3 minutes for the signal to get back. So, yeah.
And also, like, think about that for, like, my planet that I love, Saturn, and, like, having Cassian and, like, other, you know, orbiters over there, and how much longer that takes. And you could also Google that, but it takes longer.
It's a long time, yeah. To Jupiter, it's almost an hour. So Saturn's even further, right? But yeah, space is big.
Yes, and our data, it does travel. It takes time. Okay, the next question by Anonymous. Besides the rover, what else is on the cutting edge of the field right now? What excites you all the most? So for everybody.
Okay, I'm going to jump in because I'm very excited and want to get my answer out there. But I'm very excited about space, very excited about exploring other planets. I'm actually going to be, this is like self-promo, but yeah, I'm completing summer research, engineering research with a professor at Swarthmore, and we're going to be designing and making a swimming robot that would swim underneath the ice of Europa, which is one of Jupiter's moons. And this is actually a mission that JPL are going to do. And I know someone who works at JPL, and they were like, yeah, you should do this because that's what's going to be coming up. So I am so excited for the summer. But yeah, I'll let someone else talk. Otherwise, I won't stop talking.
That's really cool. Julian, do you want to take a stab at this?
Yeah, sure. I personally don't in my own research don't do planet stuff, so I don't really have anything related to Mars or the other planets that I'm super excited about. But I'm really excited about in terms of like galaxies and the formation of galaxies and the history of the universe. There's lots of exciting thing that's can happen, and the James Webb Space Telescope is going to hopefully be released later this year finally, and it will tell us a lot of things about the early ages of the universe, and also planets and other solar system, other galaxies and solar system, which will be exciting for a lot of people. So I guess James. No.
Yeah, sure. Yeah, so I don't really do research that's related to planetary or solar system scale things. However, I am like a massive nerd for space exploration anyways. So I'm really excited about NASA's Dragonfly mission coming up in a mere 2036, 15 years. It is basically like a drone that is going to be going to, like a helicopter style drone that is going to be going to Saturn's moon of Titan. And it's going to have a lot of really interesting science on it. I think it's like a fascinating engineering problem to work out. I was reading about it the other day that I think they'll be flying on the order of kilometers per flight, hopefully for like a mission period of like a year. So it's going to be an unprecedented amount of distance traveled on another celestial body. And Titan's a really interesting place, so I think there's a lot to learn.
Kate, do you want to go next?
I'm not sure if I have a good answer for this one, but I did notice that there was a question in the chat that I wanted to get back to, and it was saying, are there more ways to make the wheels for the rover? And I wasn't sure if that was referring to the cardboard like tutorial that I introduced, but if it was, I think that those wheels could be made out of almost anything. And I mean, you could play around with shapes. You could try with triangular wheels. I suspect that's not going to work out very well, but you could try with so many things. You could try with wheels with a star shape. You could try with wheels made out of, I don't know, a larger rover, maybe with wheels that are a CD. You could try, maybe not a CD. I hesitate to say that now because I don't want you to damage a CD if you have one around. But I chose to make them just out of cardboard. I want to say that in my like second version, I used part of like a matzo box. You could use a cereal box. You could use cardboard from mail you've received. And I think that, yeah, I might have traced them with a mug. And so that's an easy way to find something circular. And a lot of the things that had been in the original tutorial, in my second prototype, I actually changed them out. And so I want to say that you could try almost anything. And if it doesn't work, you could try something else with the knowledge that you've gained through the process.
Yeah, definitely. I feel like a big part of science in general is just trial and error. And like you might have a crazy idea and it might sound crazy, but once you test it, you never know. But I'll answer this question real quick. And then
Can I just one comment? There's this really cool app from the Science Museum in London, which I know about this because I took my kids to the Science Museum in London several years back. But you can build a rover like in any weird shape. I mean, it's not in real life, it's in a computer game. And then you can see what the weird shaped rovers do. It was really fun. We spent a long time building weird shaped rovers. So you might enjoy that. I put it in the chat and we'll send it out otherwise as well.
I want to plug my exciting research now. I study gravitational waves, and I'm going to be studying with Andrea Lohman at Haverford this summer. And basically, the thing I'm excited about is this future space-based gravitational wave detector. But I'll stop there because we have other questions. But yeah, I like gravitational waves and using pulsars to measure them. But Karen, did you want to answer something that excites you right now?
Oh, okay. Well, I'm going to go for imaging black holes. And so that was in the news last year, the Event Horizon Telescope. But they keep saying they have more, and they might have an image of the black hole in the center of our own galaxy. And I think that would be incredibly amazing to see. So I'm really looking forward to that coming out.
Oh, man. So questions are rolling in. Karen, do you have any advice? Should I go with the chat or the questions in the QA?
It's you pick, Sam. What do you want to answer? We may not have time to get to everything, right? But answer some. Yeah.
But please come back to future programs, and because as you can see, the questions roll in towards the end. Okay, so we'll do an older one from the chat, the QA box. If Mars doesn't seem to be applicable for humans, which planet or moon might be more appropriate? So this kind of goes back to our talking about the moon with water and the future Saturn missions.
I think honestly, all depends on future technology. We know that there's something called, I think it's called the Goldilocks corridor, I want to say, where Earth is situated. And it's basically this really, if you imagine like the solar system, there's kind of a strip where Earth is situated, that if we weren't there, life wouldn't be able to exist. So the likelihood that we could just hop on a spaceship, go to another planet and just be able to live there without anything, never going to happen. But I think honestly, technology in my mind has no limits. I guess it probably does, but like I'm an optimist. But I think if we think about how far we've come, especially in the past, say 30, 40, 50 years, they're already planning to send, well, SpaceX are especially wanting to send humans to Mars by 2024. So I think that's the first step in trying to kind of live on another planet.
Yeah, Mars, of all the solar system locations, Mars is the closest to Earth-like conditions in terms of having a surface, and the temperature range is not comfortable for humans, but it's not like minus a million or something. That doesn't even exist, but you know what I mean. It's late on a Friday. There are some interesting ideas about moons around Jupiter, which maybe get a bit of extra heat from Jupiter. So, but Mercury's way too close to the sun, way too hot, and Venus has really nasty atmosphere, so that's no good. And then there's no land on Jupiter, Saturn, or the other gas planets. So, yeah.
I was wondering, Julian, you mentioned the James Webb Space Telescope, right? Was that you?
Yeah, so I assume you're going to ask me the question in the chat.
Yeah, there's a question in the chat. I don't know anything.
I'll read it first, if that's, or you can do it. Yeah. You can read it.
Go ahead.
So this question is asking about the most significant findings of the James Webb Telescope are expected to be, and so it's like basically the next generation of the Hubble Space Telescope, in that it will be able to take much more. I think it has a wider field of view, but also more detailed, in-depth observations, which will let us see galaxies and groups of galaxies that are further away. In earlier, we were talking about travel times earlier, which galaxies are even much further away, hundreds of millions of or billions of light years away. And the further away they are, the longer the time takes to get to us. So when we see galaxies that are further away, we're seeing further back in time. And so we can learn about the earlier times of the universe that way.
So there's better technology every day.
Yeah.
Okay, well, I think this is where we wrap up. It's 9:23, and usually we end at 9:20. So thank you so much, everybody, for being here and asking amazing questions. Please come back and ask more. Yeah, have a good weekend, everybody. And join us for next month. I don't have the date off the top of my head, but we're going to do multi-messenger